Hi, everybody. Great job in week 5. I apologize for the slight delay in getting the assignments graded for that week. The grades should now be available in Blackboard, and for the most part, everyone did a great job on those assignments. Keep up the good work there. Just a couple of general comments with respect to last week's assignments. One, in the Gretel assignment, you were asked to only use observations where the school type was regular. Here you needed to restrict your sample to only those observations. We saw this actually in the first Gretel problem set, but people perhaps forgot or just didn't see that instruction to only use those particular observations. You wanted to use the SMPL command in Gretel in order to accomplish this. It would have been SMPL and then the condition, school type 1 equal to 4, and then dash dash restrict for your option in order to restrict your sample to only those observations where that condition holds, or where the school type was regular in this case. You can always revert back to the original full sample by just typing SMPL dash dash full to revert to the full sample once again. Pay attention to units of measurement, especially when it comes to interpreting estimated slope coefficients in a regression analysis, and pay attention to what's the outcome variable and what's the predictor variable. For example, in the paper and pencil problems, income was measured in thousands, teacher salary was measured in thousands. In the Gretel assignment, SAT scores were measured in points. What I'm getting at here is, one, we want to be clear that the interpretation of the slope coefficient is what happens to average y, the outcome, for a 1 unit increase in x. So we want to be clear about that, but also always provide as much information as possible in your interpretations. Be specific as possible. What do I mean? It's far more informative to say we estimate that average SAT scores increase by 9 points from a $1,000 increase in teacher salary than to say we estimate SAT scores increase by 9 units from a 1 unit increase in teacher salary. Be clear about the units. It's far more informative to whoever is reviewing your results or reading your research. What else? It turns out that R squared actually will not change if you regress y on x or if you regress x on y, meaning if you switch your predictor and your outcome variable, R squared is going to be exactly the same. However, it is best to interpret it as the percentage of the total variation in the outcome that is explained by its linear relationship with the predictor. Pay attention to the difference between a confidence interval for an estimated slope coefficient and a prediction interval. They're fundamentally quite similar in nature in that they're both intervals that we're calculating to give us a sense of the precision of our estimates, but one is for the estimated slope coefficient and one is for our predicted values, our y-hats, if you will. I recommend that you refer to the formulas toward the end of the slides for Module 3, Week 5C, in order to see how to calculate those intervals for our predictions. Okay, we're now into multiple linear regression analysis, where we're including additional predictor variables on the right-hand side of our equation. This allows us to get more reliable estimates of the independent relationship between each x variable and y. It allows us to control for additional variables and therefore potentially help us get closer to establishing a causal relationship. But I'll just say that when it comes to using observational data, we typically need more than simply including additional x variables in order to establish any sense of causation in our estimates. That's about all I have for now. As always, please reach out if you have any questions, and good luck finishing up Module 3, and we are almost on to Module 4. Take care.